Good day everyone. Welcome to my physics tutorial. This is Sir K at your service. In today's episode, we look at a typical problem in hydrostatics involving one application of Pascal's law. How is this principle applied in a common hydraulic lift? Find out, watch, and learn. Question number 1. The small piston of a hydraulic lift has a diameter of 8.0 centimeters and its large piston has a diameter of 40 centimeters. The lift raises a load of 15,000 Newton. Question letter A. Determine the force that must be applied to the small piston. And question letter B. Determine the pressure applied to the fluid in the lift. Shown in this figure is a schematic diagram of a hydraulic lift, also called a hydraulic press. A hydraulic lift is a force multiplying device, right? With a multiplication factor equal to the ratio of the areas of the two pistons. Like in this example, the ratio of the area of the big piston, capital A, to the area of the small piston, small letter a. Alright? So a hydraulic lift basically consists of a small piston, alright, in a cylinder. When the small piston is pushed down over a small surface area, alright, the pressure is produced in the hydraulic liquid. Alright? So inside the vessel is a hydraulic fluid, uh, usually a mineral-based oil. Alright? And since we know that liquid is incompressible, the input pressure, alright, the input pressure in the small piston is just equal to the output pressure, alright, or the pressure that is exerted by the hydraulic liquid on the bigger piston. Alright? And as we know, pressure is just the amount of force F divided by the area. Alright? And this force is directed such that it is always perpendicular to the surface area of the piston. So for the smaller piston, we represent the applied force in terms of small letter f and the area of the piston in terms of small letter a. While for the big piston, the force F here is represented by capital letter F. Alright? That implies that the amount of force is relatively large. But that is over a relatively large area of the piston. So capital F divided by capital A is the amount of pressure, alright, exerted by the hydraulic liquid on the big piston. Alright? And that big amount of force that is created or produced is just enough, okay, for the big piston to be able to lift a heavy load such as an automobile. All right. So this part of the hydraulic lift system, all right, is literally what we mean by a hydraulic lift, because it is able to lift or uh, raise a heavy load such as the car, just like in most car service stations that we have around. The operation of a hydraulic lift is based on Pascal's law. All right. Pascal's law states that a pressure applied to a fluid in a closed container is transmitted equally to every point of the fluid and the walls of the container. Such devices like the dentist chair, car lifts and jacks, many elevators, and hydraulic brakes, all of them use this principle. So moving on to our solution, for question letter A, we are looking for the force applied to the small piston, and we label it as small letter F. So this force can just be determined by multiplying the area of the small piston, denoted by small letter A, and that will be multiplied to the amount of force capital F, which represents the load that the big piston will be lifting, and then divided by the area of the big piston capital A. All right. So substituting our data, all right, for the area small letter A, we have pi r squared. Okay? The radius of the small piston is 4.0 centimeters. So you've got to square that, multiply it by pi, and then multiply it by the load or the force big F, 15,000 Newton. And then divide again by pi, uh, which will be multiplied by the radius of the big piston, 20 centimeters, that will be squared. All right. So doing our math, we will get the value for the small f, or the force exerted on the small piston, equal to 600 newtons. All right. So for question letter B, which is asking for the amount of the pressure that is exerted on the hydraulic liquid. All right. And that is represented by the letter small p, stands for pressure. All right. We just divide the amount of force that is exerted on the small piston, the value for small letter f, which is 600 newtons, and divided by the area of the small piston, that is pi, multiplied by the square of the radius, which is expressed already in meter. So again, doing our math, we will get the amount of the pressure exerted on the liquid pressure equal to 1.2 times 10 to the fifth power Pascal. So this is the amount of pressure that the small piston exerts on the hydraulic liquid, all right, inside this vessel, which, according to Pascal law, this pressure will be transmitted to all parts of the hydraulic lift system, including this part, all right, where the liquid is exerting a bigger force F on the big piston. So the same pressure of 1.2 times 10 to the fifth Pascal will also be exerted by the liquid or the hydraulic liquid on the bigger piston, which is what produces the big force F, big enough to be able to lift a heavy load such as the car. All right, so this device is what we usually see in most car service stations. All right. Our last question, question number 2. The piston of a hydraulic car or car lift is 0.30 meters in diameter. What gauge pressure in pascals is required to lift a car with a mass of 1,200 kilograms? Also, express this pressure in atmospheres. All right. So when we say gauge pressure, we just uh, referring to the excess pressure above the atmospheric pressure. All right. Atmospheric pressure at sea level is equal to 1.01 times 10 to the fifth Pascal. And when we say absolute pressure, okay, what you mean is the total pressure, which is the sum of the atmospheric pressure plus the gauge pressure. All right, so the answer to this question, we can determine the gauge pressure simply by dividing the amount of force F exerted by the big piston. All right, in this case, it is given as the amount of the load or the weight of the car that is going to be lifted by the big piston. All right, and that will be divided by the area of the big piston, capital A, which when we substitute, we have 1,200 kilogram. That's the mass of the load. So we need to multiply it by 9.8 meters per second squared to get the weight, and then divide that by pi r squared. All right. Um, what's given here in the problem is the diameter of uh, the piston, the big piston, equal to 0.30. So half of that is 0.15 meters, which is the radius. All right. So just get the square of the radius, multiply that by the value of pi, 3.1416. All right. And that becomes the divisor for our uh, equation here. Again, doing our math, we will get the gauge pressure equal to 1.7 raised to the fifth power Pascal, which when converted to the unit atmosphere, all right, uh, 1 atmosphere is just equal to 1.01 times 10 to the fifth Pascal. So using that conversion factor, we will get the equivalent of our answer. The gauge pressure 1.7 times 10 to the fifth Pascal is just equal to 1.7 atmospheres, two significant digits. All right, so those are the answers to question number 2. And so we are done with our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page and please don't forget to subscribe to my YouTube channel.